Let's start with our first chapter, the understanding of numbers. So numbers are classified into various ways: positive number, negative number, even number, odd number, natural number, whole number, rational, irrational, real, unreal. There are a lot of ways that to qualify numbers. So we will study few of those classification today. So first of all, the first classification is natural numbers. The first classification is natural numbers. So what are natural numbers? I hope all of you must have understood, read it about in your previous classes as well. So natural numbers are the numbers starting from 1 and 2, 3, 4, 5, 6, 7 and so on. So natural numbers are basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. So basically our numbers. Then the next come whole numbers. The next classification is whole numbers. So what are whole numbers? Whole numbers are nothing but natural numbers in addition to 0. So basically whole number starts from 0, 1, 2, 3, 4, 5, 6 and so on. So basically in whole numbers all the natural numbers are included as well as 0. Fine. Then next come our integers. Next come our integers. Now what are integers? Integers are the collection of all the whole numbers in addition to the negative numbers, the negative natural numbers. That means integers will be, let's say it will be definitely they contain the whole numbers as well, 0, 1, 2, 3, 4 and so on. And natural numbers on the negative side, that is they are called negative numbers, that is -1, -2, -3, -4 and so on. So I hope you all are getting the idea what are natural numbers, what are whole numbers and what are integers. And you must have encountered them, the definitions, the word, the terminology a lot many times in your previous classes as well. Then comes the non-integers. Then comes the non-integers. So what are non-integers? Non-integers are the number which contains a decimal value as well. Non-integers are the numbers which contain a decimal value as well. For example, 2.6. 2.6 is a non-integer. If I just say 2, then 2 is an integer. It does not contain any decimal value. But 2.6 contain a decimal value, that is 0.6, right? Same way 3.4567, again it is a non-integer. Non-integers can also be on the negative sides as well. -3.6, again it is a non-integer. -4.78, it is a non-integer. 0.23, it is a non-integer. So non-integers basically are all those numbers which contain a decimal value as well, and integers do not contain a decimal value, and both of them can be on the positive side as well as on the negative side. Fine. Now comes the major classification, which is rational numbers and irrational numbers. But before we go into that, before we go into the classifications of rational numbers and irrational numbers, let us first understand what are the different types of decimal numbers we can have. Please pay attention. Let us first understand what are the different types of decimal numbers that we can have. Okay, so see, I can write a number, let's say 2, right? If I write a number 2, I can also represent it as 2.0. Does it make any difference? 2 and 2.0 are the same thing. 3.0, they are also same thing. So basically we can say that these are integers only. These decimal numbers are integers only. They do not have any decimal value after the decimal point, if 0 is not counted as a decimal value. But let's take another example, 2.01 or 2.354 or -7.86, -9.1392, right? So they are negative as well as positive numbers and they contain some decimal value. But what is so special about their decimal values? before before I tell you the speciality of their decimal values, let's come to another classification. Let's take a number which is, let's say 3.111111, and it continues. I'm sure all of you must have seen these kinds of number as well, and it is represented as 3.1 bar. What is the meaning of this 3.1 bar? That means 1 is written a very large number of times, and very large in mathematics term we say infinity. 1 is written infinite number of times, like you can keep on writing 1 1 1 1 1 whole of your life and still that 1 will not get finished. Let's take another example. Let's say 2.7373737373 and so on. So this we can represent in a short form as 2.73 bar. That means 73737373. This pattern is continuing and it never ends. We can keep on writing 73 infinite times. Let's take another example. 5.67777777 and so on. In short notation we can write it as 5.67. Now which number is repeating again and again and again? It is not 6, it is just 7. So I should put my bar over 7 only. So this means it is 5.67777777. If the bar is over 67, then it would have meant 5.67676767 and so on. So now I guess you will be able to understand the difference between these type of numbers and these type of numbers. What is the major difference? The major difference is that the decimal of these numbers end. There is an end to the decimal values. There is nothing after 2, there is nothing after 6, there is nothing after 4, there is nothing after 1. So these type of decimal numbers are called as terminating. These type of decimal numbers are called as terminating decimal numbers. That means they terminate, they stop at a certain value. So at the same time, what are these kind of numbers? These kind of numbers are non-terminating. But there is a special case with them. They are not only non-terminating, but these numbers are recurring as well. Recurring means that there is a pattern. If I ask you what is the next number that you can write over here, you will say, of course sir, it is 1. What is the next number that you can write over here? You will say, of course sir, it is 73. What is the next number that you can write over here? You can say, of course sir, it is 7. So basically there is a pattern that is forming in, although they are not terminating, they are not ending, but still there is a pattern in these numbers. You can predict what is going to be the next number. So these type of numbers are called as non-terminating. Of course they are non-terminating, but they are recurring as well. Non-terminating, recurring. So I hope you all of you got the meaning of the word recurring. Recurring means a repeating pattern. You can predict the next decimal number. Fine. So we have integers which are basically, there is no decimal values. Then we have terminating decimal values. We have non-terminating decimal values but recurring. So the next classification is non-terminating, and non-recurring. Non-terminating and non-recurring. Let me give you an example of these type of numbers. Let's say it is 2.415823019 and so on. We can keep on going like this. Let's take another example. Minus 1.4178903588, right? And we can keep on going like this. So now, as you can see, non-terminating means the decimal values will never end. They will keep on going like this. But please pay attention on the word non-recurring as well. These numbers are non-recurring as well, which means there is no specific pattern. Can you predict the next number? What is going to be the next number after 8? No. what is going to be the next number after 9? We cannot predict, right? Until and unless we know some exact values and so on, we cannot predict what is going to be the next number. So there is no pattern in the decimal values. So we say these type of numbers are non-terminating and non-recurring. Fine. Now, can there be numbers which are terminating but recurring? See, we had terminating, we had non-terminating and recurring, and non-terminating and non-recurring. Can we have terminating and recurring? Just think about it. If the decimal values are terminating, how can they recur? They cannot recur, right? If they terminates, there is no point of recurring. Can 1392 repeat itself? If it repeats itself and keep on repeating, it will become a non-terminating number, right? So we cannot have terminating but recurring. That is meaningless. Fine. Now, before starting these classification, before I told you these 4 type of numbers, decimal numbers that we can have, what was our initial point? Our initial point was to understand what are rational numbers and what are irrational numbers. Now, if I say that these 3 type of numbers, if I say that these 3 type of numbers, the numbers which are integers, terminating decimal and non-terminating but recurring decimals, they are called as rational numbers. They are called as rational numbers. And the only single type of numbers which are non-terminating and non-recurring are called as irrational numbers. They are called as irrational numbers. Now, why such classification? What is so special about these numbers that these numbers do not have? Or else what we can say, what is different between this set of numbers and this set of numbers? The major difference, which is also the definition of rational numbers, is that rational numbers, and I recommend all of you to please note down this in your copy as well. The definition of rational numbers. Rational numbers are all those numbers which can be represented in the form of P by Q, where Q should not be equal to 0. So this is the definition of rational numbers. And the special thing about integers, terminating decimal numbers as well as non-terminating but recurring decimal numbers are that those numbers can be represented in the form of P by Q, that is in the form of a fraction, and where Q should not be equal to 0. How we can do that? For example, let's take a very simple number, 2.3. Can I write 2.3 as 23 by 10? Aren't they the same thing? So here 23 is our P and 10 is our Q. So 2.3, which was a terminating decimal number, we can represent it in the form of, we can write it in the form of 23 by 10, which is in the form of P by Q. Let's take another example. Let's take minus 1.5. Can I write it as minus 3 by 2? Isn't 3 by 2 equal to 1.5? So basically, again, a terminating decimal number, I am expressing this in the form of a fraction. Fine. And how to express non-terminating but recurring numbers in the form of P by Q, that you will learn in your higher classes. But I think this understanding for now is enough for you guys. Okay. So as you can notice, there are 2 parts in this definition. One, that the number can be expressed in the form of P by Q, right? There is another part which is more like a precaution, that Q should not be equal to 0. Now what does this mean? Why this precaution? Why this precaution is there? Why do we have to take this precaution that Q should not be equal to 0? To understand this, let's understand the basic definition of a fraction. In a fraction, you have a numerator and a denominator. And numerator upon denominator, if you do the division, it will give you a quotient, right? That means numerator is equal to your denominator into the quotient, right? Isn't it correct? So basically, for example, it means if I write it as 6 by 3, we all know it is 2, right? So basically 6 is equals to 3 into 2, the denominator and the quotient. The numerator is 6, the denominator is 3, and the quotient is 2, right? So numerator is equals to denominator into quotient, right? Now I hope all of you guys also know that if we multiply any number with 0, the answer is always going to be 0. If we multiply any number n with 0, the answer is always going to be 0. I hope all of you know this, right? Very simple enough. Now, if I write a fraction 0 divided by 2, and if I ask you what is the quotient, right? So the answer is going to be 0, the quotient is going to be 0, but how? See, we can express this in this fraction that is 0 by 2 in this form, right? So 0 is equals to 2 into q. Am I correct? Of course I am correct, right? So q, what should be the value of q? I am multiplying 2 with a number and the answer is 0. So isn't the value of q is 0? Isn't the value of q should be 0, right? Because only if you multiply a number by 0, the answer can be 0. Fine. So I could have chosen any number other than 2 also. So 0 divided by any number, the fraction is always going to be 0. But what if 0 is in denominator? Let's take another example. Let's say 2 divided by 0, and I am asking you what should be the quotient? What should be the answer of this number 2 divided by 0, and what should be the answer, right? So we can write it like this: 2 is equals to 0 into q, right? Now just think about this equation. This side it is written that 0 into some number, which is 2, and we all know that 0 into some number should be 0. The 0 into any number should be 0. Then what is 2 doing over here? This whole equation has become meaningless. This whole equation has become meaningless. So basically, and I hope all of you will note down this in your copy as well. So basically, if we have 0 in our denominator, that means any number n divided by 0, the answer is not defined. There is no way in mathematics that we can tell what is going to be the answer if we divide any number by 0. But if 0 is in numerator, the answer is always going to be 0. So that's why we have taken a precaution over here that whatever you do, please do not put your denominator as 0, because if you put your denominator as 0, the answer is not defined. That number is meaningless number. So that's why we have taken this precaution. After rational numbers, next come our irrational numbers. Irrational numbers. So obviously all those numbers which are not rational are irrational. All the numbers which are not rational are irrational numbers. That means these irrational numbers cannot be expressed in the form of p by q. And what is their decimal representation? Their decimal representation, as we understood earlier, was the decimal representation will be non-terminating and non-recurring. So decimal representation will be non-terminating and non-recurring. So let's take some examples of these numbers. Your root 2, root 3, root 5, root 7, all these numbers are irrational numbers. Pi is pi as well is also an irrational number. Have you ever seen the representation of pi? 3.14. This we take as an approximate number, but pi goes on and on and on and on without ending and without repeating. There is no pattern in the decimal number of pi, in the decimal representation of pi. Similarly, root 2, root 3, root 5, see root 2 we take an approximate value as 1.41, but this value goes on and on and on and on and on, and it never ends, as well as it does not have any pattern. So please note down this. We can say that the square root of imperfect square. I hope all of you know the meaning of imperfect squares. What are imperfect squares? Like 2 is an imperfect square. There is 3 is an imperfect square. But is 4 an imperfect square? No. 2 square is 4. So 4 is a perfect square. Now 5, 7, 6, 8, they are not perfect squares. But 9 is a perfect square. So square root of imperfect squares are irrational. All of you please note down this point in your copy, as this point is very important for doing questions. Square root of imperfect square are irrational. So why? Because if I take square root of 4, that is 2. 2 is an integer, it is a rational number. So it is not an irrational number, right? It is a rational number. So square root of a perfect square will be rational, but square root of imperfect square such as root 3, root 8, root 10, all of these will be irrational numbers. In addition to this, there can be a lot of other irrational numbers as well, but in our syllabus we have to just note down this important point for our irrational numbers. So after having understood rational numbers and irrational number, the next question comes: is there something beyond them as well? Is there any classification which is above them as well? The answer is yes. Real numbers. All rational numbers and irrational numbers are part of real numbers. And what are real numbers? Real number is any number that you can think of. Any number that you can think of. So the next question arises, sir, are there any numbers which are unreal? The answer is yes. But the good news is we will worry about them in higher classes, not right now. So real numbers are all the numbers which you can think of, and all the numbers that you can think of will be either rational or irrational. All the numbers that you can think of will be rational or irrational, right? Then just to summarize what we have studied till now, so rational and irrational are part of real numbers. Now you all know irrational number is which is not rational, so they have to be separated. Now integers are a part of rational numbers, right? Integers are a part of rational numbers. Now what about non-integers? Non-integers, few of them can be rational and few of them can be irrational. Like for example, pi, the value of pi 3.1478910, I don't know what it is, but it is an irrational number, right? Non-integer, let's say 2.6, it is a terminating decimal, right? So it is a part of rational numbers. So non-integers can be either rational or irrational. Fair enough? I hope you don't have any doubt till now. So now integers, all the whole number are part of integers, correct? Every whole number is an integer, but every integer is not a whole number. And next come natural number. Next come natural number. So natural numbers are a part of whole numbers, whole number are a part of integers, integers are a part of rational numbers are a part of real numbers have another part which is called irrational numbers, and there are few numbers which are not non-integers, they can be either rational and irrational. Not same at the same time, but few of them are rational, few of them are irrational. Okay, for example, 2.6 minus 9.8, these are rational. Root 2, root 3, root 4, sorry, not root 4, root 2, root 3, root 5, root 7, all of these are also non-integers, but they are part of irrational numbers. Okay, and as I was saying, every integer is not a whole number, but every whole number is an integer. Why? Because whole number just contains 0, 1, 2, 3, 4, right, and so on. But integers, in addition to containing all the numbers, also contain -3, -2, -1, 0, 1, 2, 3, right, and beyond -3 as well, that is -4, and so on. So integers have negative numbers, whole number does not have negative numbers in them. Natural numbers are basically 1, 2, 3, 4, 5, they do not have 0, whole number have 0 as well. So this statement, the same statement which we use for integers and whole numbers, we can use for whole number and natural number as well. Every natural number is a whole number, but every whole number is not a natural number, the difference being 0. As I said, that real numbers are all those numbers that you can think of, right? And all those numbers, you have been learning this since your childhood, that all the numbers can be represented on the number line, right? So basically, number line represents all the real numbers. It will contain every type of number that we can think of: rational number, irrational number, whole number, natural number, integer, non-integer. So our age-old number line is a representation of real numbers. Our age-old number line is the representation of real number. Every real number, that means every number that you can think of, is in this number line. For example, 2.6, isn't it here, right? My 0.5, it is over here, right? These are our natural numbers, 1, 2, 3. If we include 0, this will become our whole numbers. If we include negative integers, then it will, if we include negative numbers, then it will include our integers. If we include the numbers with decimal values, they will become non-integers. Non-integers are also here. 1.7 is here, 1.77 is also here, right? Any number that you can think of is here on this number line, correct? So any number that we can think of is either rational or irrational, so they are also here. Numbers are infinite, that means there are infinite rational numbers, there are infinite irrational numbers. Now the main thing which we want to focus on and which will help you in doing the questions will be, all of you know that if we move from left to right on our number line, the numbers keep on increasing. Like 2 is greater than 1, we all know that. 3 is greater than 2, we all know that, right? Is -1 on the right of -2? Yes. So that means -1 is greater than -2, right? And -2 is greater than -3, right? So please note this point, that if we move towards the right, the numbers keep on increasing, that you know. So that means the smaller the magnitude of a negative number, magnitude means this 1 is the magnitude, 2 is the magnitude, 3 is the magnitude. So the smaller the magnitude of a negative number, the greater that number will be. The smaller the magnitude, the greater the number. That means -4 is greater than -10. -6 is greater than -7. -7 is greater than -15. Although 15 is greater than 7. 15 is greater than 7. But -15 is less than -7. I hope all of you are clear about this point. So if I have to put -2.6, where should I put it? Is -2 less than 2 -2? Sorry, -2.6. Is it less than -2 or greater than -2? -2.6 will be less than -2. That means it should come towards the left side of Q. but it is greater than minus 3. That means it should come towards the right side of minus 3. So minus 2.6 will be in between minus 2 and minus 3. Or if we want to tell it from smaller to greater, minus 2.6 will be in between minus 3 and minus 2. Fine. So with this, the key points, there are some key points that I think all of you should note that will help us to do the questions. So the key points are, number 1, which is our smallest natural number? The smallest natural number is 1. The smallest natural number is 1. Which is our largest natural number? What? Largest natural number? Sir, we cannot think about it. It is infinite. It will keep on going and going and going. We cannot think about our largest natural number. So there does not exist any largest natural number. Second point, what is the smallest whole number? Smallest whole number is 0, right? Because there is whole number starts from 0. So basically we cannot have any number, any whole number which is less than 0, right? And as we did in the case of natural number, what can be the largest whole number? We cannot think of it. So the largest whole number does not exist. It will go on and on and on and on and on. Any number that you can write, there is another number which is larger than that. So we cannot think about any largest whole number or a largest natural number. But third point, which is the largest negative integer? Which is the largest negative integer? The largest negative integer is minus 1. The largest negative integer is minus 1. Isn't it correct? Because integers are minus 5, minus 6, minus 7, minus 8, minus 3, minus 2, minus 1, 0, 1, 2, 3. So in amongst all these integers, which is the largest negative integer? It is minus 1, right? Then next come, which is the smallest negative integer? Same reasoning as natural number and whole number. Negative integers on the left side will go on and on and on and on. We cannot think about any smallest negative integer. Now the next point, what about 0? What about 0? Is 0 a negative number or a positive number? Now about this, please note that 0 is considered neither positive nor negative. Fine. I hope all of you have understood all this theory part that I have taught till now. Now we will move on to doing some questions for practice. So let's move on to our first question. What is the double of the units digit of the greatest 4-digit number formed out of the given digits, which are 2, 7, 2, 7, 8, 5, 9, 1, right? So out of these given digits, we have to form the greatest 4-digit number and we cannot repeat the digits, right? So let me make 4 blanks and these blanks represent each of the digit. Okay, so to form the greatest number, as all of you know, we should start with the highest available number. So the highest available number is 9, then next comes 8, right? And then next comes 7 and after that comes 5. So 9875. This is the greatest number that we can form out of these available digits. Fine. And which is the digit in the units place? It is 5. And what is the double of 5? It is 10. So the answer is 10. The second option. Move on to our second question. If we form smallest 5-digit number out of 4, 3, 5, 8, 7, 2. Out of 4, 3, 5, 8, 7, 2. Then what is the difference between the place value and the face value of its 100th place digit? Now I have taken this question to make you understand the difference between the term or the meaning of the term face value and place value. So first of all, let's form a 5-digit number, the smallest 5-digit number out of these given numbers, right? And we cannot repeat the digit. Okay, so 1, 2, 3, 4, 5. I have made 5 blanks. Now, if we have to make the smallest number, shouldn't we start with the smallest available number, which is 2, right? So 2, then comes 3, then comes 4, then comes 5, and then comes 7. So 23,457, 2, 3, 4, 5, 7. This is the smallest possible number that we can make out of these given digits. Fine. And what is at the 100th place? 100th place means this place. Okay, the number 4. This is at the 100th place. Now, the difference between the term face value and place value. Place value means the value which this number is getting from this place. I'll repeat it again. The value which this number is getting from this place. So this number 4 is at the 100th place. So what is the place value? What is its place value? Place value is 400. That is the value which this number is getting from this place is 400. And what is the face value? Face value means the number itself. Face value means the number itself, which is 4. And the question asks us to do the difference between both of them. So 400 minus 4 is 396, and that's our answer. So I hope you have understood the meaning of the term place value. So what is the place value of 5 here? Place value of 5 here is 50. What is the place value of 7 here? It is 7 itself. What is the place value of 3 here? It is 3000. Getting my point? And what is the face value of 3? It is 3. What is the face value of 4? It is 4. What is the face value of 5? It is 5 itself. So face value means the number itself, and place value means the value that the number is getting from its place. So let's move on to our third question. Find the greatest and smallest 5-digit number from the digit 0, 1, 2, 3, 4, 5, 6, 7 without repeating, and add these numbers. What is the place value of the number of the digit in the 1000 place of the number? So basically what we have to do, first of all, we have to make a greatest 5-digit number out of these available numbers. And as all of you know, to make the greatest number, first of all, we should write the highest number first, that is 7, then 6, then 5, then 4, then 3. Fine. And to make the smallest number, now this is the greatest number out of these available digit. Now what about smallest number? What about smallest number? Let's say, let me make a blank. 1, 2, 3, 4, 5. 5 blanks, 5 digits. Fine. And as we have discussed in the previous question, to make smallest number, we should start with the smallest digit. What is the smallest digit over here? 0. Then next comes 1, then next comes 2, then next comes 3, and then next comes 4. So the number is 0, 1, 2, 3, 4. But wait a minute, wait. Isn't it something is wrong over here, right? If we have 0 in the front, isn't it just a 4-digit number instead of a 5-digit number? It violates our requirement of the question. We had to form a 5-digit number. So that means we cannot have a 0 in front. So my friends, please always keep attention of this point. Please do not make silly mistake while doing question. To make smallest number, don't ever start with 0, because if you start with 0, your one of the digits will be vanished. So other than 0, what is the next possible number? What is the next possible smallest number? It is 1. So we have to start with 1. Now next we can keep the next possible smallest number, which is 0. So instead of keeping 0 in the first place, we have to keep 0 in the second place. So the number will be 1, 0, 2, 3 and 4. So out of these available digits, the smallest number we can form is 1, 0, 2, 3, 4. Now the question asks us to add both of these number and obtain a sum. So what will be the sum of these two numbers? So it will be 3 plus 4, 7, 4 plus 3, 7, 5 plus 2, 7, 6 and 8, right? And then the question is asking us what is the place value, of the digit at the thousands place. What is the place value of the digit at the thousand place? So which digit is at the thousand place? Ones, tens, hundred, thousand. So 6 is at the thousand place. So the place value of 6 will be 6,000, and that is our answer.